Welcome to the session of fluid mechanics, a part of fluid kinematics, the concept of streamline. First of all, we come to the basics. Then, what is fluid kinematics? The fluid kinematics is basically deals with the geometry of the motion of the fluid particles without concerning about the cause. Okay. So when we come to the concept of streamline, what is a streamline? Okay. The streamline is nothing but the imaginary series of imaginary lines at any instant of time, and if we draw tangent at any point on the curve or line, and curve is basically the more generalized term than curve, then line, then we will get the velocity of the fluid particles at that point. Okay. So what is the physical interpretation? Is that these are the series of imaginary line in a flow field. Okay, in a region. Then what are these series of imaginary lines? These are the path locus along which the fluid particle is flowing in a flow field. What is a flow field? A flow field is a region where the hydrodynamic parameters basically changes with position and time. Okay, so if suppose we plot a point P1, suppose P2, okay, and now according to the definition, if we draw tangent, then we will get the corresponding velocity. Okay, and the important thing about streamline is that this curve is being generated at instantaneous time t, suppose small t. Okay, so the question arises like that: what is the philosophy behind it? The philosophy is that suppose you have a camera, okay, and the fluid is flowing in a flow region, okay, and now you click a photo at a particular instant of time, then you will see that the fluid particles are at different positions moving along certain locuses. Okay, and now at every point in the locus, if you plot a point and draw tangent, you will get the velocity of that fluid particle along that locus. Or any point on that same locus of another fluid particle, if you draw a tangent, you will get the velocity of that another particle. So basically, this concept of streamline is that basically the series of imaginary lines, okay, and at that point if we draw a tangent, we will get the velocity. Okay, and now another very important thing is that 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 is that this mapping is being generated at time t. Okay, this mapping is generated at time t. Then what will happen to this mapping for later instant of time? Okay, so it will depend on the type of flow, that is the whether it is steady flow, whether it is unsteady flow. What is a steady flow? Steady flow is a flow where the hydrodynamic parameters like pressure, velocity will change, that is will not change with respect to time, then it is a steady flow. Okay, and for if the hydrodynamic parameters basically changes with time, then it is basically unsteady flow. Okay, then for a steady flow, this mapping for later instant of time will be identical. Okay, but for anything other than that, for unsteady flow, this mapping will be different. Okay, now another important property of streamline is that two streamline cannot intersect at a point, suppose P naught. It cannot intersect. What does this signify? It signifies that at a particular point P naught and particular instant of time t, the fluid particle is having two components of velocity, that is spread action. A fluid particle at a particular instant of time at a particular position in the fluid field, in a flow field, will have a unique velocity associated with it. So the two streamlines cannot intersect. Okay. Now this is the theoretical concept. Now we come to the mathematical point of view of streamline. Okay, that is the equation of streamline. So what is the equation of streamline? This is the velocity. Okay, if we extend this line, just rubbing this off just to make it clear. Okay, I'm just extending this tangent. If we cut a small path along the tangent, suppose ds vector, then this velocity vector and ds vector are in same direction. Okay, then what will be the equation of streamline? That will be v cross into ds vector equal to 0. Okay, and we all know that this v vector is nothing but ui cap plus vj cap plus w k cap. This is the velocity in the x direction, velocity in the y direction, velocity in the z direction, and I, j, k cap are the corresponding unit vectors. Same which can be expressed for displacement, that is dxi dyj plus dz k. Okay, and this thing can be expressed in the form of a determinant, that is I, j, k, u, v, w, dx, dy, dz, and that will be equal to 0. Okay, simple as that. Okay, now if you solve this, we will get the condition of streamline, that is what? Dx by u, dy by v, dz by w. This is basically the condition. Okay, this is basically the condition of streamline. And what does this locus represent? This locus represents the stream surface. The stream surface at which this streamline, these imaginary lines are being generated. Okay. So, if a fluid flowing in a region satisfies this condition, then that fluid is having a streamline force. Okay.